You just took a test on integrals. So I'm not going to go through these in quite the detail I did the others. As a matter of fact, I went ahead and got a pretty good head start on them. Number 22, it's just a flat out add 1 to the exponent, divide by the new exponent. Number 23, I rewrote it with its negative exponent, and then I did the add 1 to the exponent, divide by the new exponent. Very little algebra involved in making it look like the key. Number 24, I distributed. Oh, you'll not forget to do that because you had to do it on your test. Distribute through the parentheses, add 1 to the exponent, divide by the new exponent. 25 was so easy I didn't even write the problem down. You just have to review your rules. Then I got to 26 and decided we would do this one together and review our U substitution for a definite integral. So far I have chosen my U, and I left off my 1/2 power there. There it is. So my U is equal to the inside function, 9 minus x squared. Du is the derivative of that times dx. So now I'm going to update my limits of integration because I like to do that. So I have U is equal to -3. So 9 minus -3 squared, which is 0. And U of 3 is equal to 9 minus 3 squared, which is 0. So what I have here is the integral from 0 to 0. Ooh. Integral from 0 to 0 of x times u to the 1/2. Doesn't really matter what else I write down because the upper and lower limits of integration are the same. My answer is going to be 0. Now what if I had not updated my limits of integration? Let's see if I would have gotten the same answer. So assuming I didn't update the limits of integration, I would say I have x times u to the 1/2 du over 2 times x. My x would cancel with my x. I would have 1/2, and I add 1 to the exponent, divide by the new exponent. I bring my x back, so I have 9 minus x squared to the 3/2 over that 2 cancels with that 2, so just 3, evaluated from -3 to 3. And what happens when I plug in -3 and 3? Well, I get 9 minus 9 both times. Big fat 0. So that one's just a big fat 0. Next one is your fundamental theorem of calculus problem. Even easier than the one that you just had on your test because you just have a plain old x sitting up at the top. Integral from 2 to x. Actually, I don't even need to write the problem down. I'm just going to plop x's everywhere I see t's. So it's the natural log of e to the 3x plus 100 times square root of sine of 3x. And remember, if instead of having a plain old x at the top of that integral, if you had x squared, then you would need to multiply by the derivative of x squared. Number 28 is just a plain old distribute. Well, actually, you could do it either way. You could distribute the 2x, or you could do it with u substitution and let u be equal to 3x squared plus 10. So you got 2 options for that one. Number 29, work on that one. we'll meet back here and compare answers for 28 and 29. Okay, I was gone for a while because I did both of those problems 2 ways because I just had to, because it's fun. So first I distributed the 2x through the parentheses, and it was a really simple add 1 to the exponent, divide by the new exponent problem. I did simplify the arithmetic there. Then I did it with U substitution, and I got what looked like a completely different answer. So we had to prove to ourselves that it's actually the same. Now remember, answers to indefinite integrals are families of solutions. So when you add this plus c here, that really means that it's equal to the terms with the variables in there plus any constant in the whole wide world. Doesn't matter what the constant is, it's plus some constant or no constant. It could be 0. So I come down here, I FOILed that out, I distributed the 1/6, and I see that my part that has variables in it is exactly the same. It just has this constant term here. So it doesn't really matter. It is the same answer. You could say that this constant is equal to 100 over 6 plus a different constant. So constants are very fluid because the important part is this, because if you take the derivative of this, or if you take the derivative of this, you end up with the same thing, and that's what makes it the right answer. The other one, if you happen to remember the rule for the inverse tangent, that the integral of 1 over x squared plus a squared is equal to 1 over a times the inverse tan of x over a, then you just go directly to answer. Otherwise, you divide everything by 9 and make it look like inverse tangent's derivative, and then you substitute, and you end up with the same darn thing. Okay, number 30 looks a lot like number 29, except you have the x on the top. So that's a straight out u sub, easy u sub, easy u sub. Look at each piece separately. Distribute the 2x, u sub, and u sub if you wanted to. I'll go ahead and write them up, and I'll do a quick go through. So I'll meet you back here and go through each of those really quickly. Okay, even though 30 looked a lot like 29, 29 was an inverse tangent, 30 is a natural log because of the x on the top. You let u be equal to the denominator, magic happens, voila. Let's see, 31 was a super easy u substitution. As a matter of fact, if you did that substituting in your head, I would not be offended. Same with number 32. If you did that substitution in your head, I would not be offended nor surprised. Number 33, you just had to rewrite it as a negative rational exponent, and then it was super simple. Number 34, you needed to distribute that to x. You could have u substituted with 5 minus x is equal to u, but you still would have ended up distributing something through a set of parentheses. So you just as well do it with x's. Number 35 was a very simple u substitution, way simpler than the one on your test with the sine and cosine of pi times something. Then I turned the page over. We had a u substitution problem. You just had to have faith that it was going to work, and it did. When you took the derivative, you were able to factor the 3 out, and then you had the x squared plus 1 to cancel with the x squared plus 1. Number 37, I went ahead and updated my limits of integration. U is equal to the thing inside the parentheses. We ended up going from -1 to -8. Remember, you have to put them in the same place as what you plugged in, even though you're going from a bigger number to a smaller number now. And keep going, and somehow I lost my negative sign. It should be a negative answer, because when you take the cube root of -8, you get -3, but when you raise it to the 4th power, it becomes a positive. You get a -2. When you raise it to the 4th power, it becomes a positive 16. Same with -1. The cube root is -1, but when you raise it to the 4th power, you get a positive 1. Going to close it down, and then we'll start with all sorts of other questions on the next video.